Hello everyone. So today we are going to solve this GCSE Combined Science Foundation Paper 1 of Chemistry. This is from 2025. Before starting, if you want to join me for online classes, you can text me on WhatsApp. This is my number 9205948909. Okay, I also take free classes on Teams. If you want link, you can text me over here on WhatsApp, or you can comment um, down there. Okay, let's start. This is our first question. This question is about atoms and ions. The model of the atom has changed over time. Okay, so in the early model, as you can see, this is the model which is showing the model of the atom. So discovery of subatomic particles led to change in the model, right? So what was the first particle to be discovered? So it was electron. Electron was the first particle to discovered. Remember the structure of atom. In at the center we have proton and neutron, and around that electron revolve in the orbits, right? Protons are positively charged, electron negative, neutrons have no charge. Remember that. So at the center of the atom, what do we have? Nucleus, right? What is the charge? No charge. Again, here electron is negative one. It has negative charge. Proton has positive charge. Neutron has no charge. So it is 0. Now, what is atomic number of an atom? Atomic number means number of protons. Okay. So, and remember, number of protons are equals to number of electrons. And what is mass number? That is proton, number of protons plus number of neutrons, which is in the center, at in the nucleus, right? Um, Now we have given a table here. Isotopes A and B are shown. We have to calculate relative atomic mass of the element. The formula is given. So basically, this is the formula: mass number times percentage. So what is mass number for isotope A? Mass number, this is for A, right? This is 10, and then percentage is 19.7. So 10 times 19.7, if we multiply that, what we will get? We'll get 197, yeah. And then if we multiply these two, this is what we will get. Then we have mass number times percentage of isotope B. So 11 times 80.3 here, and if we times that, 11 times 80.3 is basically 880.3, and if we add 197 and this and divided by 100, this is what we will get. And because it says to one decimal place, so the answer is 10.8. Next, we have this, you know, oxygen atom, which has 8 electrons, and electronic structure of here is given. Then this is showing two models of sodium chloride. This is model A, model B. So we have to take which two advantages of model B compared to model A. So these are the two correct one. Model B shows 3D arrangement of ions. So because model A only shows individual ions in 2D, right? You can see they are individual ions. But model B is showing how the ions are packed together in 3D lattice structure, right? And then it says model B shows the relative size of the ions, because in model B, the spheres of the chloride are shown larger as compared to the sodium ions, which are the positive ones, right? Which is reflecting the size difference, right? But here they are roughly the same size. So that's why these two are correct. Then the symbol of lithium is just Li, and this one is basically which electrons are involved in metallic bonding. Lithium has metallic bonding, right? So in metallic bonding, metal atoms, they lose their outer shell. Outer shells are also called valence electrons. See, these electrons are no longer attached to specific atom, and they are free to move throughout the whole structure. So this is why they are called delocalized electrons. So delocalized means they are free to move, okay, throughout the whole structure. And the inner shell electrons, they remain fixed in the place around the nucleus. Why? Because the attraction between the proton and electron is more, right? With the outer shell, they, they can, the attraction between proton of nucleus and electron is less here because the distance is more. That's why they, become free first and then the inner shell comes. Okay. So yeah. Oh, actually, this should be outer shell, right? Delocalized electron from the outer shell. This is the correct one, not the inner shell. Because as I said, inside proton, we know there are, inside nucleus, there are proton and neutrons, and electrons revolve around it, right? Electrons are negative and protons are positive. So there is attraction between them. The closer the electron to nucleus, the more attraction would be there, right? And as we increase the distance, this electron and this proton, they will be having less attraction as compared to these two. So it should, that's why they delocalize electron first. It happens in outer shell. Okay. Then we have this one. So the lithium, we have to, so these are substance, these are the particle diagram. Lithium solid is this one because you can see it is in solid state. Identical atoms are packed together in a regular and repeating pattern, which is also called lattice. Then fluorine gas is this one. Fluorine is diatomic element. Like fluorine gas means F2. Like oxygen is diatomic oxygen gas. So its atom travel in pairs. You can see there are two atoms, right? And they are like far apart, these molecules. So that is showing that they are gas. Then lithium fluoride solid is this bottom diagram because lithium fluoride solid is ionic compound. In nature, it forms a giant ionic lattice where two different types of particles, lithium ions and fluoride ions, are arranged in a regular pattern. Then this one is okay. This is showing different substance, their electrical conductivity when they are solid and when they are liquid. So lithium fluoride is ionic. Which substance is lithium fluoride out of these? So out of these, if you see, um, basically, um like when solid, lithium fluoride is ionic compound. So ionic compounds, they have specific electrical conductivity, right? But they are poor conductors because the ions are fixed in their lattice and they cannot move when they are solid. And when they are liquid, they are good conductors because the heat provides enough energy to break the ionic bonds between them and allow the ions to move freely and carry an electric current. So basically, substance C is poor conductor in both states. As you can see, substance D is poor when solid, and liquid, when it is liquid, it's good. So that means this is D, right? Is And substance E is good and good. So it can be a metal, right? Because metal is, good conductor when it is solid or liquid. Okay, now let's see next question. Okay. So we have here carbon. This is one form of carbon. So what is this form of carbon? This is showing, as you can see, C3D. Some lattice is there. Every carbon atom is bonded to four others, right? Like this one is bonded 1, 2, 3, 4. So this is basically this is diamond structure because this one is usually spherical and this is hexagon. Graphite is hexagon, so this structure is of diamond. Okay. Okay, next one we have to find the relative formula mass, and for this CF4. So CF4, what we need to do, whatever is there, like the value of carbon and fluorine we have. So C is, there is because this is CF4, right? So C is 12 and there is nothing over here. So we'll just times it by 1. Uh, the 12 with 1 because 12 is the atomic mass for carbon. And then for fluorine there are 4 atoms, right? So you will times this by 4, because there we have 4 atoms, and then we add these two and we get the mass. The next one is this nitrogen atom. It is asking total number of shared electrons. Shared electrons make what type of bond? Covalent bond, remember, right? And so just remember that whenever two electrons combine, they make single bond. Okay, and so 4 electrons are required for double bond, and for triple bond 6 electrons are required. Even you can count 1 2 3 4 5 6, these are electrons. And between nitrogen gas and 2, there are triple bond. So one bond means 2 electrons, so even you can just count it, right? So these are 6 electrons. And then this is asking complete the sentence. Lithium and nitrogen, they form a compound, which is this Li3, and which is also called lithium nitrite. So this is called lithium nitride. And then next question is neon. Okay, neon does not react with the elements to form compound. Why it does not react? Why it is unreactive? Because it comes, even if you check the periodic table, it is found in group 18. And all the elements which are in group 18, they are called chemically inert. Inert means they are unreactive. Why? Because they have full outer shell of electrons. So neon has full outer shell, that means it has 8 electrons in its valence shell, which is full. And the full octet is shows stable structure. Stable means it does not need to gain or lose electrons or to share to form bonds. That's why it is unreactive, because it has stable arrangement of electrons. Then we have this, as this is showing a experiment, and it says complete the word equation for the reaction. So when magnesium react with oxygen, it make magnesium oxide. Okay, next one is complete the sentence. So what is happening here? Oxygen is added, so oxidation reaction, because magnesium atoms are gaining oxygen, okay, to form magnesium oxide. So in chemistry, oxidation is addition of oxygen to form a substance. So this is oxidized. Magnesium is oxidized because it has gained oxygen. Then next one is this, where we have to find the mass of the magnesium alone. To So basically, like here we will have to subtract the mass of the empty one from the um, like the one which is containing magnesium, right? So if you see this, this is 20.55, right? And this empty is 20.25. So calculate mass of magnesium before heating. So if we need to subtract, because this is for before heating, we need to subtract the empty one, and this will just give us the mass of the magnesium, right? So now it is asking, why does the reaction result in increase of the mass of the content? Because magnesium react with oxygen gas from the air and it form a solid magnesium oxide. Okay, and since the oxygen was not weighted initially, as it was in the air, so the final solid product weighs more than the starting solid magnesium. Okay, so because solid is reacting with the gas to produce a solid. So yeah, now let's go to next question, which is this. So it is asking to draw a ring around anomalous result. So as you can see, most of the point on the graph follows a very straight line starting from the origin, right? So what is anomalous? Let's first talk about this. It in this experiment, the mass, because anomalous result basically is the data point that does not fit the overall linear trend which is formed by the other results. Okay, so in this experiment, heating magnesium to form magnesium oxide, the mass should increase proportionally, right? So an anomalous result is too low. That is one often happens because of, if magnesium didn't react completely, or this, I mean, if there is incomplete reaction or something. So if you see this, I think I should use a different pen. Okay. So the point, which is like, if you see these lines, they are going in straight line, right? So this point is anomalous result, right? Showing because it does not fit in the overall linear um, trend, right? So it's not the blue, this one is not the correct, only this point is there. Okay, next one is this. So it is asking to calculate mean value of x. So there are four tests. Okay, so we have to find mean. The formula to find mean is simple, just add all the values, okay, and divide it by the number of values, like 1, 2, 3, 4. So we added all of them, we divided by 4, and the answer is going to be just add them and divide it by 4, and that's your answer. Okay, the next question is this. The student used Bunsen burner instead of a water bath to heat the crucible. So why did student use a Bunsen burner? Because a water bath can only reach a maximum of 100 degrees Celsius, which is boiling point of water, and magnesium needs much higher temperature to overcome that energy, activation energy to require, which is required to react with oxygen in the air. Okay, and yeah, this is the reason, or it can be because of the because this is a combustion reaction. A Bunsen burner provide the intense direct heat, right? Also, the crucibles are made up of ceramic specifically to withstand the high heat of a flame, and they won't dissolve in water. So that's why. Next one is this. So here a student did the a different student did the investigation. Student heated the crucible for 1 minute instead of for 5 minutes, and student obtained different result. So we have to give reason why student obtained different result. This is because the reaction was incomplete, because when heating a substance in a crucible, usually to cause a chemical change like thermal decomposition or to drive off water, the process takes time. So heating for only 1 minute instead of five, it likely didn't, provide enough time or energy for reaction to reach completion. So maybe because of this, not all of the reactant reacted, right? And so this is why you can write incomplete reaction. Okay, next one is, this is about metals, and complete the sentence. Most metals are found in the earth as compounds. So because metals are chemically reactive, and they make bond with other elements like oxygen or sulfur in earth's crust. Because of this, they are found as the compound means elements, when they combine in a specific ratio, they form compound. So because metals are reactive. So next is iron is extracted from iron oxide by reduction with carbon. Why is iron extracted by reduction with carbon? Because iron is less reactive than carbon. So in a chemical reaction, a more reactive element can displace a less reactive one, okay, from its compound. Because carbon is more reactive than iron, it can successfully remove oxygen from iron to leave behind pure iron, and this is called reduction. This question, let me see. So aluminum is extracted by electrolysis of aluminum oxide, and this is the setup. And it is asking the mixture of aluminum oxide and cryolite has a lower melting point than aluminum oxide alone. Why is the melting point lowered? So basically, The correct option is to reduce the amount of energy used, because pure ammonium oxide has a very high melting point over like 2000 degrees Celsius, and melting it on its own would require a lot of electricity and heat and energy, which will be very expensive. So by dissolving aluminum oxide in molten cryolite, so the melting point of mixture is lowered to about 950 degrees Celsius, and which reduce energy cost and protect the equipment by lowering temperature, and so this is what is the reason behind it. Then we have next question. After some time, the positive electrodes need to be replaced. Why must the positive electrode to be replaced? So basically, the option is the electrodes react with oxygen gas. In electrolysis of aluminum oxide, the positive electrode, which is also called anode, they are made up of graphite, okay, which is made basically carbon form. So during electrolysis, negatively charged oxygen ions, they migrate to positive, because negative and positive they attract, where they lose electrons to form oxygen gas. And at the high temperature of the cell, this oxygen gas react with the carbon anodes. So this reaction produce carbon dioxide, which cause electrons to gradually burn away and disappear. So because the electrons are physically consumed by this reaction, that's why they are replaced regularly. Okay. And after this we have this question. So aluminum can be mixed with other metals to form alloys, right? So how does the hardness of an alloy of aluminum compare with the hardness of pure aluminum? Tick one box. So the alloy is harder than the pure metal, uh, because in pure aluminum the atoms are all of the atoms are same size, and they are arranged in a very regular and neat layers. So these layers can easily slide over one another when force is applied, right, which make the metal relatively soft and malleable. But when aluminum is mixed with the other metals to form alloy, the new atoms are usually a different size. Suppose these are aluminum, this is a new one. So these different size atom, they disrupt the regular arrangement, right? Like suppose this will go something like this, and these different size atom, they will disrupt and regular arrangement, and they and lock the layers in place. So this make it much more difficult for the layers to slide off, and which make it hard and strong material. That's why they are used as, that's why we make alloys. So this option is correct. And then I'll see quickly this one. Okay. So aluminum can form alloy with silver. So this figure is showing how melting point of alloy changes with percentage of silver in the mixture. Describe how melting point of alloy changes as percentage of silver in mixture as the mixture increases. Use data from figure 9. Okay, this is figure 9. So as the percentage of silver is increases from 0% to approximately like 70 something, 70, this is 70, and this is 72, let's say. So the melting point is decreasing, right? You can see the graph is going downward, from 600 something, let's say this is 650. Okay, and the melting point reaches its lowest value, which is about, you can see here, about 540 degrees. And when the mixture is roughly 72%, when this silver percentage is 72, as the percentage increases after 72 up to 100, the melting point is increasing sharply until it reaches here, which is very close to 1900 something, 950, right? The which is the melting point of pure silver. So whatever I just explained, you can write this here. Okay, so first you can explain how it is decreasing, it reaches here and then increases, and where this final point. And then we have this. So this question is about acid, and this is showing the setup of an experiment. And this method does not give an accurate volume of alkali needed to react completely with the acid. So we have to suggest two improvement to this method. So basically here he is first is he is using we can use a burette instead of dropping pipette. A burette allow for much more precise measurement of volume added, okay, to like to something 0 0.0 something compared to counting drops which can vary in size. Also we should use a pH probe or meter instead of this universal indicator paper, okay, which give us pH in digits like pH is 6 or something like that, instead of using this paper. These two can help us to improve. So first use burette, and second is pH meter, which give us digital values. And then we have this one. So pH of a solution when universal indicator turns green, so it is 7, which is neutral. Then next is what name is given to the reaction between acid and alkali, so which is called neutralization, because base and acid, they neutralize each other and produce salt and water. This is called neutralization reaction. Next is which ion do all acid contains? So H plus. Okay, so the acids have H plus and bases have OH minus, right? You have to remember this for the exam. Name the acid that react with sodium hydroxide to produce sodium nitrate. So we have nitrate here. See, so it will be nitric acid. You can guess from here what acid is this, because this is salt. Okay, nitric acid. It is explaining neutralization reaction. When acid react with base, it produces salt. It's like nitric acid react with sodium hydroxide, produce sodium nitrate. Then we have this one. This diagram we have to label A and B. We have energy here and this. So A is this A is the overall energy change. So A is overall energy change. This represents the difference in energy between reactants and the products, right? You can see this difference between this and this is called overall energy change. B is the progress of reaction. On x-axis we see progress, which shows the reaction as it happens over time. So B is progress of reaction. Okay. Okay, we have it here. So this is A and this is B. I didn't see that. Okay. And yeah, I think this is all. Okay, next one, acid also react with insoluble solid to form a salt solution. When making a salt solution, excess solid is added to acid. Draw apparatus and used to separate. Okay, so basically what we can draw here is, I can just tell you, to separate insoluble solid from liquid, you can use a filtration setup, right? Filtration method. And drawing should include like filter funnel, a cone shaped funnel, you know, something like this. And filter paper, we need a filter paper which is placed inside funnel, which trap the excess solid. And then we will put a flask or a beaker here and place it underneath the funnel to collect the solution. So I think you can see the filtration picture from the Google and you can draw it. Then 5.8 is solid X react with the hydrochloric acid to produce zinc chloride and hydrogen gas. Name solid X. Okay. So when metal and acid react, they make salt and hydrogen gas. So hydrochloric, this is acid, and the because it is producing zinc chloride. So from here you can get the guess that the metal is zinc, right? The solid is zinc. So the answer is zinc and the symbol is Zn. Okay. And then we have this is showing electrolysis of copper chloride, and this is the setup. Chlorine gas is given off during electrolysis of copper chloride solution. Chlorine gas is poisonous. Give one way to reduce the risk of harm. So we can, perfume the we can do this experiment in a fume cupboard. Okay, perform the experiment in a fume cupboard. This device safely, vents toxic gases away from the person who is conducting the experiment. Let me write here. Yeah. Yeah. Now the next one, we have given time in seconds, mass of negative electrode in grams. We have to plot time and this. So we have all the values. This is our x-axis 0 and 20.2. So if this is 20, this is 22, so this is 21 over here. This is 21 actually. So 20.2 with 0, this is this point somewhere here. Then 60 is 22 yeah, 60, so this is 50, and suppose this is 60 and 22 this. Then 120, this is 100, as you can see here, 120 and 23.4. So this is 150, right? Because this line comes between these two, and 120 will be here. This is 120. With 120 it is 23.4. So this is 23, this is 23.4. Like that you can, draw all the points. Let me quickly draw it. 180 will be somewhere here. 24.2 will be here, somewhere here. And then 240, this is 250. 240 will be here. 24.8 will be 24.8 will be here, suppose. Then 300 is this. 25.2, 24, 25 will be here. And then 360, this is 350, so this is 360. And 25.2 will be, this is 25, so this will be somewhere here. Basically draw the line of the best fit. So we'll start with the first point, which is this 0 point something. Since the mass is increasing quickly at the first and then it levels off, like you can see here, it levels off, right? So your line of best should be smooth curve, right? We can start with this. So curve will, like, it will go first. uh, you can just curve upward, and then uh, if you start at this point through the middle of the other points, I mean, this is the graph. If you can just smooth it like this, okay? So between the last 2 point, it will, stay constant, like here. Okay, so these were the data points. This line which we have plotted, this is called line of best fit. And then we have this question, 6.3. A student made hypothesis negative electrode will increase by a constant mass every 60 seconds. How do table 5 shows the hypothesis not correct? Because if you see here, change in mass between each 60 seconds is not the same, right? So for example, if mass increased by 0.06 gram, like here, change in mass is not mass in hypothesis that is stating the mass increase by constant. It's not correct, right? Because as you can see, change in mass is not the same, right? So yeah, this is the correct one. Then we have this um, the other one. It says this is 25 centimeter cube of solution of copper chloride contain 5.5 gram of copper chloride. Calculate concentration of solution. So this is We have to calculate the concentration. Okay, so first we'll convert this decimeter cube into centimeter cube. So the volume is in centimeter cube, right? We'll convert it into decimeter cube. I said it opposite. So we'll divide it by 1000 because one decimeter cube contains 1000, which will be 0.025 decimeter cube. Then the formula for concentration is mass over volume. So mass is 5.5 gram, volume is this 0.025 decimeter cube. Why I converted it? Because I need answer in decimeter cube. Here you can see, also here it is written. If you divide it 5.5 by 0.025, you will get 220 gram per decimeter cube, and that is the answer. Okay, then here the correct answer is, okay, the teacher also electrolyzed potassium chloride solution. Hydrogen gas was given off at the negative. Why was hydrogen gas given off? So because hydrogen is less reactive than potassium. Okay, because when you electrolyze a solution, both potassium ions and hydrogen ions, they from the water, they are attracted to negative electrode. At cathode, the least reactive element is always discharged. Okay, next is this one. Um, so what is meant by exothermic reaction? Exothermic means it is a chemical reaction that transfer energy to the surrounding. Okay, exo means it release energy or heat. Okay, to the surrounding, and endo means reaction which absorb energy or heat. So yeah, then there we have to calculate again. Okay, relative formula mass is given. We have to calculate percentage by mass of oxygen in calcium hydroxide. So the formula is total mass of the element, total mass of element over relative mass, which is mr, times it by 100. So total mass you can see is given as, we can find it because we have this calcium hydroxide, right? And calcium atomic mass is 16, plus OH is given again. Um, Actually, this is mass of oxygen. Okay, it says total mass of oxygen will be, okay, sorry, yeah, we have to find the total mass of oxygen. So O2, oxygen is going to be 32 because for oxygen it is 16. 16 times 2 is 32 over this, um, you know the what it is called, relative formula mass, which is 74, times it by 100, and 32 over this. If we do it, we'll get 43.2%. So I think this is the last question. Yeah, so which is asking about, okay, plan a method to investigate. Okay, I think I will explain this in next class. I have another class. Thank you.